Hello guys, welcome back. So today we're going to continue our discussion on simulation, and we'll see how different theorems can be verified using the simulation software. So here we have considered examples of superposition theorem. So in superposition theorem, as we know, it is applicable on linear and bilateral network, and the response in any branch will be equals to the individual response containing one source at a time and removing the remaining sources by their internal resistance, right? So the algebraic sum of individual circuit should be equals to the actual or total actual response of the circuit. So we have considered this circuit. As you can see here, it is mentioned in this book. So 4 ampere, 10 ohm, 10 volt, 2 ohm, 5 ohm, 3 ampere and 6 ohm. So we have here three sources. So this is our circuit. We have made it using PSPICE. So now if we run the circuit and then see whatever values we will be getting. So the current that is coming through 6 ohm is 2.037, which is coming downward. Okay, now let's see the individual responses. So if we check the individual responses, then it is in the first circuit it contains only 4 ampere source, and remaining are removed and replaced by the internal resistance. So first one, this voltage source is removed by a short circuit, the current source is replaced by a open circuit. So the current is 1.235, and in the second circuit, okay, it is not showing, so I guess we have to redraw the circuit. So let me check that here itself. I hope that will work. So we have to eliminate this source, we have to eliminate this source, we have to keep only this. So let's run the run. So the current we are getting is 3.308.64, which is in the opposite direction. Okay, and then let's see, in the final circuit we have obtained containing the 3 ampere source only, where the current is coming as 1.11 in the downward direction. So now if we check in the calculator, okay, let me remove this everything, make it 0. Now the current will be, this is in the downward direction, so 1.235, then minus, this is in the opposite direction as we have seen, so it will be 0.30864, then this is in the downward direction, so the value is 1.111. So the answer is 2.037, which was our actual answer, right? So if you want to verify that also we can do. So I can get it back like this. So if I run it, so it is 2.037. So we have got 2.037. So the superposition theorem is verified, right? So now let's check one circuit containing a dependent source. Okay, so the dependent source circuit is this one, as you can see here on the left hand side. So it contains two sources, two independent sources, which is 15 volt and 10 volt. So we have here 15 volt and 10 volt, as you can see on the right hand side, the simulation. So let me first remove the values, and now this is a current dependent current source, so which is a dependent source, and the dependence cannot be removed by its internal resistances. So that is why in all the circuits, superposition, wherever we are applying superposition theorem, the dependent source will remain as it is. So this is the dependent source, as you can see here. This is the current source, and dependency is coming from here. So the direction is this, as you can see here. So from this 15 volt, current will come to 6 ohm, and then it will move through the dependent source, and then again go back to the main circuit. So the dependency is verified. The value of this is 3I dash, so or 3I, so the gain should be 3, so we are putting the gain as 3. Okay, so now then remaining are the two superposition theorem circuits, where we can see the first 15 volt is removed and replaced by a short circuit, and a second circuit the 10 volt is removed and replaced by a short circuit. So now let's see what is the current that we obtain in this circuit. So let's run the simulation and check. So we're getting, this is 657.9 milliampere, this is 263.16 milliampere, and this is 394.74 milliampere. So now let's see whether this two addition should be equals to this one, right? So the value is 263.16, it is in direction is towards right, then plus 394.74, which is equals to 657.9, so which is exactly the same value that we obtained in the first circuit. So the superposition theorem is verified. Now if you want to see the solution, so this is 25 divided by 38, the total value. So let's see what is 25 divided by 38. So it is 0.6578, so which is this, it is in ampere. So if we consider this in ampere, so it will be 0.65790 ampere. Okay, so superposition theorem is verified. So we can verify superposition theorem like this using PSPICE circuit. So let's see similarly other circuits. So I hope instead of putting everything in one circuit, so let us separate it, and then we'll discuss that in the next video. Thank you for joining.